Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go through everything you need to know about right and non-right angled trigonometry for your upcoming test. Now, how we use trigonometry differs slightly depending on whether or not a triangle is right angled. For example, we can only use SOHCAHTOA in right angled triangles. So we need to make sure that we know how to classify a triangle. So if we have any random triangle, we let A, B, and C be the sides. We'll just call A and B here the two shorter sides and C the longer side. So it turns out here, if C is the longest side, if A squared plus B squared equals C squared, then the triangle is right angled. If A squared plus B squared is greater than C squared, the triangle is acute angled. And if A squared plus B squared is less than C squared, then it is obtuse angled. So for example, if we've got a triangle like this and we want to determine if it is right, acute, or obtuse angled, we just look at A squared plus B squared and compare to C squared. So we can easily see on our calculator that 28 squared plus 45 squared does in fact equal 53 squared. So because A squared plus B squared equals C squared, this triangle here is right angled. The right angle is always opposite the longer side. In fact, in any triangle, the largest angle is always opposite the longer side. So this triangle here is right angled, and that means, amongst other things, we could use SOHCAHTOA in this triangle. So make sure you know what SOHCAHTOA means, because we'll need it for some of the problems in this video. So let's start with a problem involving angle of elevation and depression. So here it says the angle of elevation to the top of a 60-meter building is 30 degrees. I walk towards the building, so the angle of elevation is now 75 degrees. How far have I walked? So for questions like this, worded questions, if you're not given a diagram, let's draw one. So we have a 60-meter building over here, and we're standing along here. So we're told that the angle of elevation is 30 degrees to begin with. Now, the angle of elevation is always the angle made with the horizontal. It's not the angle made with the vertical. So we can assume this is a right angled triangle, because when we talk about the height of things like buildings, the height means the perpendicular height. So what we've done is we've started here, angle of elevation is 30 degrees. Now we've walked towards the building, we've ended up somewhere over here, and the angle of elevation is 75 degrees. Remember, it's always the angle made with the horizontal. So how far have I walked? We're being asked to find this distance here. So we could actually solve for x using either the sine rule or SOHCAHTOA. We can use SOHCAHTOA because it's a right angled triangle. So that's what I'm going to do. Now we can't find x directly using SOHCAHTOA, the reason being x is not a side in any right angled triangle. But what we can do is we can find this side here, I'll call that y, and we can find this side here, which I'll call z, both of which can be found using SOHCAHTOA. So let's start with Z. So turning our attention to this smaller right-angled triangle, we have the tan of angle. The reason I'm using tan is because I have opposite and adjacent. That's what the TOA means in SOHCAHTOA. So tan 75 equals opposite over adjacent. Now, when you're using SOHCAHTOA, if you have a situation like this where the thing you want to find is on the bottom, you simply divide. So Z will actually be 60 over tan 75. Now, I'm going to leave my answer like that because I need to use this in a subsequent calculation. I need to subtract Z from Y. So I don't want to round here and introduce inaccuracies. Now, by a similar process, we have tan 30 equals 60 over Y. Y would be 60 over tan 30. So, to find x, I simply need to subtract these. X will simply be y, which was 60 over tan 30, minus z, which was 60 over tan 75. Now, when doing this calculation, we need to make sure our calculator's in degrees, because the angles were in degrees. For most calculators, you know it's in degrees because you see a little box with a D up the top, or you see the word DEG written. Make sure your calculator's in degrees. So putting that in our calculator, we get about 87.85. Because the building was 60 meters in meters, our final answer is in meters. All right, let's now look at bearings. So I drive for 160 kilometers on this bearing. How far south am I from my starting position, and on what bearing must I return to my starting position? All right, so we know for bearings we draw a compass like this, and the bearing is the angle made with the north axis going in a clockwise direction. So a bearing is just one number between 0 degrees and 360. So you may wish to put a drawing of this on your cheat sheet because it gets a bit confusing. The way that we label these angles is sort of in the opposite direction than we label the angles in the unit circle. So if we drive for 160 kilometers on a bearing of 170, 170 is between 90 and 180. So we've gone in this southeast direction. So let's draw down here. So this angle here would be 10. Because 170 degrees means the angle made with the north axis going in a clockwise direction is 170. So this angle in black is simply 180, which is due south, minus 10 gives you 170. So we've gone for 160 kilometers. Now we can turn this into a right-angled triangle. We know it's going to be right-angled because south and east are always at right angles. So we're asked how far south, so we're looking for this side here. So we simply use cos because we have adjacent and hypotenuse. That's what the CAH, C-A-H in SOHCAHTOA means. So we set up our equation. Cos of angle equals adjacent over hypotenuse. Now when the thing you want to find is on top, you times. So here x will be 160 times cos 10. So the answer is about 157.57 kilometers. So the first part of the question is done. I'm about 158 kilometers south of where I started. Now we're asked on what bearing must I travel to return to my starting position. So I'm here and I want to go here. So I need to know this angle here, theta. Let's find what theta is. Now, we obviously know theta without having to do trigonometry because the angles in any triangle add up to 180. So theta must be 80 because 10 plus 90, you need 80 more to get to 180. So theta equals 80 degrees, but that's not the bearing. So the reason is, I'll start here and draw a compass. The bearing is the angle made with the north axis going in a clockwise direction. I really want that angle there in red. So that angle there in red, which I'll call B for bearing, is going to be 270. Due west is 270 plus that extra 80. So the bearing is actually 350 degrees. All right, let's now look at another bearings question. So this time J walks for 5 kilometers on this bearing, K walks for 6 kilometers on this bearing. We're going to calculate how far apart they are and the bearing from K to J. So they're both starting here. We'll draw a compass there. Okay, so firstly, J goes for 5 kilometers on a bearing of 250. So 250 is going to be over here, just less than 270, which is due west. And J has gone for a total of 5 kilometers. On the other hand, K has gone 150 degrees. So 90 is due east, 180 is due south, 150 kilometers is going to be over there. So the angle here is 250 minus 150, which is 100 degrees. So we've drawn a diagram here, but we need to have a triangle somewhere. When we're finding sides or angles, we need a triangle. So this will be our triangle here. Firstly, we're going to calculate how far apart they are. So we have that K is over here, J is there. We simply want this distance here, X. Now note here, we can't use SOHCAHTOA because this is not a right-angled triangle. We don't even need Pythagoras' theorem to tell us that. If you have a 100-degree angle in a triangle, you can't have a right angle also. So if we are to find sides or angles in a non-right angled triangle, we need to use either the sine or the cosine rule. So they're complementary. You can use them at different times. This table tells you when to use them. So you can use the sine rule to find a side when you're given two angles and a side. You use the cosine rule to find a side when you're given two sides and angle between is what this means. You can use the sine rule to find an angle. If you're given two sides and an angle, you do need a pair, a side angle pair. Note there's an ambiguous case here. And you can use the cosine rule to find an angle when you're given all three sides. So here we have side, side, and angle in between. Two sides and angle between. We're going to use the cosine rule to find this side there. So this is the cosine rule for side. So here, C, the side we're trying to find is like x. So we have x squared equals a squared plus b squared. Doesn't matter which you label a, which you label b, minus 2ab times cos of the angle opposite the side you want to find. So if you put all this in your calculator, you get about 71.41889 and so on. But just remember, when you're using the cosine rule for a sine, you need to square root your answer. A lot of people often forget. So x will just be the square root of our answer, which is approximately 8.45 kilometers. Okay, that's how far apart they are. So now we turn our attention to finding the bearing from K to J. So let's draw a compass at the place we're starting. So we're starting here. So the bearing is the angle made with the north axis going in a clockwise direction. We want this angle here. Now we can easily find this angle here, alpha. See, this angle here, because the bearing to K was 150 degrees, this angle here must be 30 degrees, 180 minus 50. These two angles are alternate. So alpha equals 30 degrees. The reason is they are alternate. Now we can also find this angle here, theta. Theta can be found using the sine or cosine rule. We can use the cosine rule because we have all three sides of the triangle, and we can use the sine rule because we have the opposite side and a side angle pair. We now know x. We have two sides and an angle. So this is the cosine rule for angles. So when you're finding an angle using the cosine rule, the side that you subtract is the side opposite the angle you're trying to find. So theta here will be the cos inverse of a squared. Doesn't matter which you call a, so I'll call a6 plus b squared. So that's x that we found, which is 8.45 squared, minus the side opposite squared over 2 times a times b. So I've just written 8.45 here for convenience, but when I actually put this on my calculator, I'm going to use the ANS answer function when I come here to bring up the previous answer. And so putting that on our calculator, we get about 35.7 degrees. So what is the bearing? What is this angle made with the north axis going in a clockwise direction? So the bearing, which I'll call B, is just going to be 360 minus alpha, the alternate angle that was 30, minus the angle that we just found, 35.7. So putting that on our calculator, we get about 294.3. I'll just round it to the nearest degree. The bearing is 294 degrees, and we're done. All right, let's now look at a harder question. So also important when using trigonometry to find sides and angles is this concept of exact values. Now, you probably notice when you put sine, cos, or tan of a number, you usually get a really weird, it's a long, irrational number for your answer. But there are certain times, there are certain angles you can input for sine, cos, or tan that give you exact values. And these are very important when we do trigonometric equations, they're important in calculus, etc. So let's have a look first at this triangle here. I'll just start with this smaller triangle. So if I have a right angle and 45 degrees, then this is an isosceles triangle because the third angle is also 45 degrees. That means that these two sides will be equal. If a triangle has two equal angles, it has two equal sides. Now I can just let this side here be 1. It wouldn't matter if I said it was 2, 3 or whatever because everything's in the same proportion. So what I'm about to say would work no matter what I labeled the side here. So of course if that's 1, then this is 1. Now, by Pythagoras' theorem, the hypotenuse of this smaller triangle must be square root of 1 squared plus 1 squared. It must be the square root of 2. So this triangle proves here that the exact value of cos 45 and sine 45, for both of them, they equal 1 on root 2. Why is that? Well, cos 45 is adjacent over hypotenuse, 1 on root 2. Sine 45 is opposite over hypotenuse, 1 on root 2. Now, tan 45 is equal to 1. We can use the same sort of idea. Tan of this angle is opposite over adjacent. It's 1. So these are the values that you will get if you put into your calculator. So cos 45, sine 45, your calculator will tell you 0.707, which is 1 on root 2. If you put tan 45 in your calculator, you get 1. Now we can also extend this triangle here to make a larger triangle such that this one is isosceles, and we can actually use this to calculate the exact values of sine, cos and tan 22.5 degrees. See, the thing is, if this angle is 145, this angle here has to be 135 degrees. They're supplementary. Now, because we made by construction this triangle isosceles, these two angles must be equal. If a triangle has two equal sides, it has two equal base angles. So this angle here and this angle here are both going to be equal to 22.5 degrees, because 135 plus 2 times 22.5 is 180 degrees. We can now calculate the exact values of sine, cos, or tan of 22.5 degrees. Now we know this side here is the same as that one, so it must be the square root of 2. So what will be this side here, x? Well, we can just use Pythagoras. It'll be the square root of shorter side squared plus shorter side squared. So let's go ahead and we'll leave the 1 squared alone. We'll expand this bracket here. The quick way to expand the bracket is square the first, square the second, so root 2 squared is 2, and in the middle goes 2 times the product of these two terms. So it will be 2 root 2. So x here must actually be the square root. Now we've got 1 plus 1 plus 2 is 4. The square root of 4 plus 2 root 2. So we can easily come up with exact values of sine, cos, and tan of 22.5 degrees. Let's start with sine 22.5 degrees. It is opposite over hypotenuse. So it's 1 over the hypotenuse, which we figured out was root 4 plus 2 root 2. Now this could be simplified, but we won't go further with that here because the point here is the trigonometry, not to get bogged down in calculations involving surds. So let's go ahead and calculate the exact value of cos 22.5 degrees. So 22.5 degrees, cos is adjacent over hypotenuse. The adjacent side is 1 plus root 2 over the hypotenuse, which we figured out was square root of 4 plus 2 root 2. That's the exact value of cos 22.5. What about tan 22.5? Well, tan of an angle is opposite over adjacent. So it is simply opposite over adjacent. Once again, these could be simplified. We're not going to worry about that because we're focusing on the trigonometry rather than operations with surds. Alright, thank you so much for tuning into this video. Best of luck studying for your test, but you will ace it. You're a superstar. This has been the luckiest maths teacher in the world. Have a great day.